Assalamualaikum and salam sejahtera. We guys from group P1 want to present about PLC design of a modular production system. Okay, this is my group member, Muhammad Shazwi bin Muhammad Isa, Muhammad Daniel Fikri bin Muhammad Nazli, and Syaidatul Aiza binti Ahmad Sufi. Project overview. This project focus on designing and simulation an automated modular production system. The system integrate 3 station, distribution station, joining station, and sorting station. PLC programming is implemented using sequential flowchart ataupun SFC and graph set and ladder diagram. The system is simulated and verified using factory I/O, integrate with PLC sim. And the next is overall system flow. We guys start from distribution station, and the next is joining station, and the last is sorting station. And the next one is a system description. The system operates as a linear automated production line. The station perform a specific task and pass the product to the next station. The PLC control all station using state-based logic to ensure correct sequencing. And the next is a material flow explanation. The first is base material is released at the distribution station, kept it assembled with the base at the joining station, and finished product is inspected and classified at the sorting station, and only one product is processed at a time to avoid solution. And the next is a control and operation. The system start when the start button is pressed, and the sensor feedback confirm each operation before moving to the next step. Auto mode allow continuous operation, and manual mode require restart after each cycle. Distribution station. We guys using a start button and the step 1, step 2, step 3, step 3 and step 4. For the start button, we guys using a push button at initial step. For the step 1, when emit 1 bring down the base material, and the step 2, the Y1 cylinder extend to push the material. For the step 3, the cylinder retract while the motor 1 conveyor turn on to move the base. For the step 4, we just launch the material, reach the end, the conveyor turn off. For the joining station, simultaneous sequence. And step 5, assembly, pick and place, and completion. For the simultaneous sequence, this one when conveyor 1 conveyor ataupun motor 1 start moving the base piece, and the phase 2 emit 2 bring down the cap and cylinder ataupun Y2 extend and retract to position it, and the M2 move the cap. For the step 5, block conveyor stop and positioner P1 clamp the piece together. For the assembly, pick and place, and automate sequence control the axis X and axis Z, move on to pick and place the assembly. For the completion, P1 unclamp and move to P, and motor 1 move the finished assembly to the next station. For the sorting station, sorting step 1, when conveyor M1 and M2 start moving and the STP stock is active. And the next is selection ataupun alternative sequence based on the vision sensor, material sensor S2 and S3. For the step 2, sort specific material using S ataupun Y5 on. And the step 3, sort specific material using Y6 on. For the step 4, allow material to pass ataupun STP off. And step 5 is all conveyor stops. For the PLC I/O mapping, input, we can using a start button. I/O address is I 0.2, function is to start the system. For the emergency button, we are using address I0.3. The function is to stop the system. For the S1, I0.4 give signal to Y1 for push the object into conveyor. For the S2, we are using I0.5 function give signal to conveyor M1, so it will start moving. For the S3, address I0.6 function is give signal to conveyor M1, so it will stop. For the B1, I0.7 to detect the cylinder Y1 when it already extend. For the jamming sensor 1, we are using I1.2 function give signal to Y2 for push the object into conveyor. For the S2, we are using 1.3 give signal to conveyor M2, so it will start moving. For the next input is J sensor 3. J sensor 3 function give signal to conveyor M2, so it will stop. For the S4, we are using I1.0 give signal to conveyor M1, so the object from the distribution station will continue moving. For the S5, we are using I1.1 give signal to conveyor M1 to stop a movement, so it can be claimed by P1. For the S6, we are using I1.5 give signal to conveyor M1 to stop moving. For the S7, we are using 1.6 function give signal to Y3, so it can start pick the cap. For the B2, address is 1.7, the function to detect the cylinder Y2 when it already extend. For the S1, for the sorting sensor 1, we are using I2.0 function give signal to conveyor M1, so it will start moving and stop will turn on. And the next is sensor sorting S2. Address is I2.1 function give signal where the object was a metal object, stopper will turn off and Y5 will turn on. And S3, we are using I2.2 function give signal where the object was a green object and stopper will turn off. S4, we are using 2.3 function give signal to conveyor M1 to stop moving. For the sorting vision sensor, we are using I2.4 function give signal where the object was a blue object, stopper will turn off and Y6 will turn on. For the manual, we are using I2.6 function switch condition to manual mode. For the auto, we are using 2.5 and a function is switch condition to automatic mode.
Next, this output table shows all the devices controlled by the PLC in our MPS system. Each output has its own address and specific function. The output can be divided into several groups. First, conveyor and motors. The conveyors are used to move the object through its station. For example, DM1 and JM1 move the base and cap objects, while SM1 and SM2 move the assembled product. Second, cylinder and actuators. Cylinders such as DY1, JY2 and SY5 are used to push, clamp or sort the objects. These outputs control physical movement in the system. Third, pick and place system. The pick and place unit consists of axis X, axis Z and pick Y3. This system pick the cap and place it onto the base accurately. Fourth, indicators and safety device. Tower light and buzzer are used to indicate system status. Green light shows standby, yellow shows running, and red indicates emergency. Fifth, control and mode indicator. Auto and manual indicator light will show the current operating mode of the system, looping output is used to stop automatic operation after 3 cycles. In short, the output table helps us understand how the PLC controls every movement and signal in the MPS system. Next, this is our driver configuration in our Factory.io. Next, tag table. This is our input and output tag table in our TIA portal. Next, SFC or graph set design. This is our SFC graph set design. The SFC or graph set design shows step-by-step process flow, sequence of operations, and transition conditions. It helps visualize the automation process clearly. This slide shows the ladder logic diagram used in our MPS system. The ladder diagram is the main program in the PLC that controls the sequence of operation. The program starts when the start button is pressed and the system is in auto mode. When the start condition is true, the conveyors and cylinder will operate according to the program sequence. The ladder logic controls the movement of the base and cab, including the emit mechanism, conveyors, and cylinders. The pick and place operation is also controlled in the ladder diagram using axis X, axis Z, and the pick actuators. Sensors are used as input conditions so that the next operation only happens when the previous process is complete.
Next, I'm Mohammed Shazwi bin Muhammad Isa. We continue in this presentation. So now we at network 17, 18, 19, and 20. Each network had to turn on, like network 70, turn on the joining step 12. Network 18 had to on the joining step 13, and network 19, it had joining step 14, and network 20 had to turn on joining step 15. Next. So the next is network 21, 22, 23, and 24. Network 21 will have to turn on the sorting step 1. Network 22 will have to turn on sorting step 2. And network 23 will have to turn on sorting step 3. And network 24 will have to turn on sorting step 4. And the lastly is network 25 for the control unit. So this is the last in the control unit. So it will have to turn on sorting step 5. So next we will go into our power circuit. Power circuit is where the emitter, conveyor, and so on to when it will turn on. I will show you which step will have to turn on this part. As we can see, distribution step 1 will have to turn on emit 1. Distribution step 2 will have to turn on distribution Y1. This means the pusher. Next is network 28. Distribution step 3 will have to turn on D underscore M1, being conveyor in distribution. So the next is J step 1 and J step 14. This is in joining station. This work will have to turn on joining M1, the conveyor. The next is joining step 2 will have to turn on the emit2. Emit2 is where the cap. Emit1 is where the base. Emit1 at distribution and emit2 is in joining station where the cap will fall. So the next is network 31, 32, 33, and 34. In network 31, joining step 3 will turn on joining Y2, the pusher of the cap. Joining step 4 is going to turn on joining M2, where the conveyor for the cap. And the next one is joining step 5 is J underscore P1, clamp. The provisioner will clamp the base under the pick and place. So when pick and place pick the cap, it will put on correctly at the base. Next is network 34. Joining step 6 will turn on the axis X, while joining step 10 will reset axis X. Axis X is the pick and place. So it will moving in front and backward. The next is network 35. So in this network, it has two conditions. These two conditions will turn on the axis Z. So the move of axis Z, it will go upside down. Joining step 7 and joining step 11 will help it to going down, while for the reset, for it can going up back. Joining step 9 and joining step 12 will help to do that. Next is our network 36. Network 36 is joining step 8 that will functioning the peak Y3. This means it will suck the cap and break into base. Next is our network 37. Joining step 30. Joining step 30 will turn on the J underscore P1 up. This is positional where the base has been climbed by it. After it has put the cap on it, this positioner will be going up and let the object going through. Next is sorting step 1, step 2, step 3, and step 4. We'll turn on the sorting M1 and sorting M2. This is the both conveyor on the sorting station. Next is network turning 39, network 40, and 41. Sorting step 2 will turn on the sorting Wi-Fi. This means it will turn on when it detect metal object. Next is sorting step 3 will turn on as YC when it detect blue object. The next is sorting step 1. This will help to turn on the stopper so the sensor can detect what the item is and let it through. Next is network 42. Network 42 is the emergency button function. As we can see at the each output before this, it has emergency button. This is because each time if the object has stuck at the conveyor or something block it, we will push emergency button and everything system will be stopped a moment. And then if we already fix the problem on the station, we push back emergency and everything can going through. It will turn on the tower light red and buzzer. And network 43 is where the counter for auto mode. So this is where I create it. So when we use auto mode, it will looping for 3 times and then the machine will stop. Next is network 44 and 45. 44 is to turn on the tower light green and network 45 is turn on the tower light yellow. The lastly is network 46 and 47. So in this part, just a simple one. When the auto mode is on, auto light indicator will on. And when the manual mode is on, manual light indicator will turn on. Okay, now I will show my live simulation using Factory IO, TIA Portal, and PLC SIM. As you can see, I already opened my TIA Portal. PLC SIM I already turned on. PLC SIM I has put it on ready before I started. Okay, in my TIA Portal, I already compile and download the device so I can try test the functioning and I will show the demonstration. Okay, we will open our Factory IO. So we turn on play. Now I will show you the manual mode with the metal object first. When the object is out of the solution, it will go into joining station where the cap will put on the base. So once this comes to the positioner, the sensor will make the clamp positioner to clamp the base. Okay, and release. Perfect. And then positioner will going up and let the object into. Now we at the sorting station. So the metal object is the first one. Next, you will try our blue object. So I press the start button, the object will going out, then it will go into the station, and then the cap, once it comes to journal station, it will going out the cap. Then it and place, and the position will going up, and then it can. Once it going to sorting, stopper will turn on. When it come to the sensor, it will detect which is metal, green or blue. If blue, it will go middle. Next, we will try our last object is green object. Figuring this as out. Once you come to the journey station, the green cat is positional reclaim and PFS will start the job. Once you complete perfect, it will positionally going up and then it will. Okay, the stopper is on. It will detect whether it's blue, metal or green. If it's green, it will go in last one. Now, I will show the auto mode function. First, we need to put it on auto mode until the auto light is on. Then we push the start button. So this auto mode will function three times with the same thing. Once it comes to the object, it will stop. Okay. Once it detects the sensor from the sorting, it will start the second object. Okay, two has done. Now the last one. How do we start? So like I see the later dagger, I have used the emergency button if something happen. So I will show you. So when I put this button and if something happen or block to the object, I will put the stop button. Power light red will turn on and buzzer also will turn on. When I put off the emergency button, it continue back. That's the end of the simulation. Now we going back to our slide. Next is system verification. The system is fully operational and verified, demonstrating smooth material flow and an accurate assembly process. All sensors are functioning correctly to ensure precise sorting, while both auto and manual mode, along with the emergency stop, are working exactly as intended. Next is discussion. By utilizing SFC to simplify complex automation logic and ladder diagram for structured PLC programming, the system ensures a high level of efficiency and organization. The integration of timer further improves synchronization and safety protocols, while factory I/O enable comprehensive testing without the need for physical hardware. Ultimately, the entire system design is good to follow real industrial practice. Lastly is the conclusion. The project objective have been successfully achieved through the complete integration of the distribution, joining and sorting station. The system has been fully verified using simulation, confirming that the design is effective and highly suitable for real industrial implementation. Thank you for watching.